Here are the lectures for Module 6, Object-Oriented Design, and there's the outcomes at the end of the module. Make sure you go back and understand the outcomes. I've included requirements and test cases as part of this discussion, but primarily that discussion will occur as part of the project lectures, so that will be covered more in depth on Fridays. As we've discussed, there's three basic relationships between the objects. The has a relationship, one object contains another. There is a relationship, that's inheritance, where one object is a variation or an extension of another. And association, which is basically everything else. Anytime an object maybe needs some information from another object, something like that. We're going to focus on the is a relationship. Now, before we can delve into that, there's two terms that come up quite often. One is polymorphism and one is overloading. Polymorphism is directly related to the inheritance or is a relationship. Overloading is not, but because there's sometimes some confusion between the two, let's talk about both. Overloading occurs when you create multiple versions of a method with different signatures in the same class. So multiple versions of the method with the same signature cannot exist in the same class. The point is that when you call a method, the Java virtual machine has to know exactly which method to run, which section of code to run. And if you have two methods with the same signature, then it confuses the Java virtual machine. So the compiler will not let you get away with that. Now, what do I mean by signature? Remember, the signature is the name and the input parameter list. So I can have public void foo and then some code for that method, and I can have public void foo int x with some code for that method, and that's fine because when I call foo, I'm either going to call it with the empty parentheses or with an argument inside the parentheses, and the Java virtual machine can always determine which version of that method I'm calling. That's overloading. Most typically, you're going to use it to create constructors for a class. So we've talked about when you see the new keyword, you get a new object, and the method that creates that object is called a constructor because it constructs the object. Well, you can build your own constructors. You get one for free. The Java programming language will give you the default constructor for free, but you might need to do some unusual things, or you want particular forms of initialization when an object is created. And so you can build your own constructors. So that's typically where you're going to use this. And for example, I've modified the circle shape class that we have as a class example, and I've added constructors. I've got this initial one, public circle shape with nothing in it. That's really the default constructor. Once you start adding ones, the compiler likes you to also define the default. So here's the default constructor. I just set radius equal to 0.0. It's completely useless. It's an example for the class. But maybe I want to allow the user to specify a radius when they create a circle. Well, I can use overloading here. It's still called circle shape. That's the name of the constructor. But now I give it one input as a double, and that input will set the radius. Maybe I want the user to be able to set the location. I give it two inputs, two doubles, and those are used to set the locations. So you notice I've got three different signatures. Circle shape with no argument, circle shape with one double, circle shape with two doubles. Obviously I could have done with circle shape with three doubles where I set the radius, x location, and y location. All of those are unique, so the Java virtual machine can always figure out which specific circle shape constructor to call. Okay, now let's start moving into actual inheritance topics. So we said this is the is a relationship. We've talked about this previously. The extends keyword is the one that's used with the is a relationship. So here I've got classes phi, phi, fo, fum. Phi extends phi. In other words, phi is a child in terms of the parent-child relationship that we talk about with inheritance. Phi is the parent, phi is the child. Phi will inherit all of the attributes of phi, all of the methods of phi. Now, usually what you'll do is you'll just overwrite or change some of the methods. However, you can add additional attributes and you can add additional methods. Often, particularly if the base class, if the parent class is designed well, then you will simply have to overwrite the methods, modify the methods. You can keep extending. So here, fo extends phi. Well, that's another layer of extension. Fum extends fo. You probably won't do that in your projects, but you have the capability to do that. Now, why is it called a relationship? Because since phi extends phi is a phi. It is a version or a variant of phi. Similarly, fo extends phi, so fo is a phi, but fo is also a phi because it's in that inheritance chain. And you can think of this in, in biology. You have the vertebrae, mammals, dog. Dog is a mammal, but dog is also a vertebrae. You can go up the chain here. We'll talk about the advantages of that in a little bit. Now, this is what polymorphism actually refers to. It's actually referred to properly at the class level because normally the classes differ in the way the methods are written. People will sometimes ascribe it to or refer to the methods, but really this is about the class level. Polymorphism, poly, many, morphism, shape, many shapes. So you have classes of different shapes, just like you can have mammals of different shapes. A dolphin is clearly shaped differently than a goat, but they're both mammals. The advantage here is that other classes can refer to that top level class and all of them will fit. So for example, if you had a method that said, I need a mammal as an input. Okay, you didn't tell me what kind of mammal, so I can use an elephant or a dog or a dolphin or a goat. They're all mammals. This is a huge advantage. It allows you to write software that works with a bunch of lower level classes without having to constantly rewrite the software or constantly worry about what kind of lower level class you have. So for example, in my generic shape code, I've got it's in the code that we've been talking about. The generic shape is the parent to circle shape, square shape, and rectangle shape, and then the better shape controller defines the methods specific for the generic shape, and they all work. So my better shape controller, now I haven't filled these methods out yet, but look at what I've got. Find larger area, generic shape S1, generic shape S2, which means I can put in a circle, I can put in two circles, I can put in a circle and a square, I can put in two squares. It doesn't matter. If we didn't have this feature, we'd have to make a separate find larger area for two circles, find larger area for two squares, find larger areas for a circle and a square. Oh, and then I'd have to remember, shoot, did I put the circle first or the square first? By just using the generic shape, all of these will work. It's a huge advantage. You do inherit everything for free. Because the parent should have private attribute values or attributes, oddly enough, the child can't even see those. Private means private, so that only the parent can see them. However, since we are encouraging you to only reference attributes through their set and get methods, you have access to them through the set and get methods. All right. I'm completely changing topics here. I'm going to move into process, so I'm going to stop this recording and start a new.